Good morning. So, we continue our discussion on fuel cell, kind of energy storage device. So, what we have discussed in the previous lecture, if you see that what is the basic principle of a fuel cell, how it works, what is the importance of a fuel cell, why it is required, and then we have seen different types of fuel cells. So, in a very basic the concept of fuel cell is that it actually produces electricity and heat using a fuel like hydrogen. Okay. Along with that, it produces water. So, that means it seems that it is completely a clean process of generation of electricity or power or energy. We have also seen what are the different structure of different fuel cells. So, in a very basic configuration, what we have discussed in fuel cell is that it is a device where you have a cathode, an anode and an electrolyte. So, fuel is pumped in one of the electrode and oxygen is sent to another electrode and eventually we generate water, heat and electricity. So, depending upon the configuration of various the cathode, anode and the electrolyte which is used, the various fuel cells are defined, particularly the electrolyte which changes from one fuel cell to another fuel cell. So, let me again make a comparative study of all the fuel cells. So, you see that I discussed that AFC, PAFC, SOFC, MCFC, PEMFC and DMFC I just mentioned. Other fuel cells I discussed with the configuration, but if you look at how they are different from one another. So, just look at few quantities which actually define a fuel cell and characterize a fuel cell. So, if I consider a common electrolyte and in case of AFC, it is actually an aqueous solution of potassium hydroxide soaked in a matrix. Okay. Now, you come to PAFC. PAFC is basically a liquid phosphoric acid which is used in as electrolyte. SOFC electrolyte is different. We discussed that SOFC is basically the solid oxide fuel cell. So, the electrolyte is also a solid and the electrolyte which is used in SOFC is yttria stabilized zirconia. Okay. And then MCFC, we have liquid solution of lithium, sodium, potassium etc. Okay, as electrolyte. PEMFC, it is again solid organic polymer, okay, and DMFC, it is solid polymer membrane. Okay. So, what we can see here, there are different electrolytes which are used for different fuel cells. And the main reason behind this is that what we have also seen in the previous class, in my previous lecture, that how the efficiency and output power varies when we go from one fuel cell type to another fuel cell type. So, now coming to some basic quantities like what reaction you see at anode. So, if you consider an anode reaction, you can see for AFC it is H2 and OH minus giving H2O and electron. However, in case of PAFC, it is actually H2 breaks into H plus and 4E minus. In case of solid oxide fuel cell, what we generate with the reaction is O2 minus and H2 generating H2O and again electron. in case of MCFC, actually H2O reacts with CO3 2 minus carbonate ion and gives H2O, CO2 and electron. PMFC, it is simple, hydrogen breaks into H plus and E minus, and DMFC, it is actually the reaction of C3OH and H2O giving rise to CO2, H plus and E minus. So, depending upon which electrolyte you use, the anode reactions vary, okay, and what are the products you get at anode. But every step what we know that there is a flow of charge, that is flow of electron in the outer circuit giving rise to electricity or power. Now, coming to cathode reaction, it is OH minus which is generated in AFC. If you look at PAFC, it is H2O. Look at SOFC, it is O2 minus. Okay. Look at MCFC, it is CO3 2 minus. Okay. And then for PMFC, it is again H2O which is generated, and DMFC is again H2O. And for each, the output, okay, we have a typical reaction corresponding to each fuel cell which is happening at cathode. Okay. It is also very important to look at that what are the charge carriers in different fuel cell. Okay. So, if you look at the charge carrier wise variation, then in case of AFC, the charge carrier is hydroxyl ion, that is OH minus. For PFC, it is H plus. For SOFC, O minus. For MCFC, carbonate ion, CO3 minus. For PMFC, again H plus, and for DMFC, it is H plus. Okay. So, these are way the chemically there are variations in different fuel cell. Now, we have to look at that what are the fuels that we have used in different fuel cells. I discussed in the previous lecture, but let me just summarize that what are the fuels used for different fuel cells. So, you see for AFC it is pure hydrogen which is used as fuel. For PAFC also it is pure hydrogen, okay. But for SOFC it is hydrogen, CO, CH4 etc. MCFC also same as SOFC. By PMFC we have pure hydrogen and DMFC C3OH. So, there is variation in fuel also, okay. And then of course, we have to look at oxygen, oxidant. So, when we use AFC, it is oxygen in air, PAFC also oxygen in air, SOFC oxygen in air, MCFC oxygen in air, PMFC oxygen in air, and DMFC oxygen in air. Okay. For oxidant, we just pass oxygen in another electrode. Okay. Okay, fine. There are some other quantities which also defines the variation in fuel cell, but I am not discussing it in detail. You can look at this literature and find, but these are few important chemical aspects which are important to know when we go from one fuel cell to another fuel cell. Okay. So, now what we have made a variation, we made a variation of chemicals. Okay. Now, let us look at in terms of output. So, what I told that a fuel cell, it generates electricity and heat, and it is a clean process. So, now when we consider one fuel cell to another fuel cell, what are the output power that we expect? Okay. So, as per literature, if you look at the output power, it is for SOFC, you can see we have very high output power. So, it is almost 3000 kilowatt output power, but its operating temperature is also very high, 1000 degree centigrade. Now, coming to MCFC, which gives around the 700 kilowatt power, means operating temperature is slightly less as compared to SOFC, and now here it is PAFC, this is AFC, and this is PMFC. Okay. If you remember that I told you in the previous lecture that fuel cell is a particular device which can replace or which can be used in small portable device also, and also for large electricity generation. Okay. So, if you go to a rural area where the gridded system is difficult, or if you go to a complete housing complex where you need a kind of power supply from a particular, like we use a DG set or something, but you can have a stack of fuel cells. Okay. From the stack of fuel cell you can supply the entire power to that particular, say, housing complex or a colony. Okay. So, therefore, the utility of the fuel cell is not restricted like some other storage devices to only to some kind of equipment, some kind of the applications. It is a widespread, and therefore, it is important that you choose which fuel cell is required for which power requirement. Okay. Now, you have a complete variation of power of different fuel cells, okay, and that is, it is up to user to choose the fuel cell of what power is required and what is the operating temperature that one works comfortably with. Okay. So, this particular graph gives us a very clear idea about that. Now, it is also important to look at efficiency, how efficient they are. So, efficiency wise, if you see, there is not much variation when you go from one fuel cell to another fuel cell. That is what we discussed. So, this is for PMFC, this is for PMFC, this is for AFC, this is for PAFC, this is for MCFC, and this is for SOFC. Of course, it is like a little bit of higher efficiency you get for PMFC, almost 80% or slightly higher. In case of SOFC also you have a higher efficiency, but other fuel cells also are efficient enough to deliver the power. Okay. So, this makes a complete idea about various fuel cell in terms of their chemistry used or the chemical used in the fuel cell, in terms of product, in terms of fuel used, and in terms of variation of power, and in terms of variation in energy. Okay. So, now there is a very important question. Okay. From the beginning I was telling that it is a very clean process. Okay. Now, the clean process depends on what fuel you are using. Suppose I consider hydrogen as a fuel, all right. Now, the question is what clean hydrogen I am using as a fuel. Okay. Therefore, one very important characteristic feature of a fuel cell is reduced harmful emission. You can see other storage devices, we have discussed many other storage devices, and everywhere we found that there are some issues with the emissions. Okay. Fuel cell in its basic configuration seems that there is hardly any harmful emission, because the byproduct is only water, heat, and electricity. Okay. But now, when you use say hydrogen as a fuel, one is to be very careful that which hydrogen you are using, because that this has to be integrated with the fuel cell. The source of hydrogen or the storage, hydrogen storage is integrated with the fuel cell. And in the previous lecture I have also shown you a model car where the storage tank of hydrogen is there in one unit inside the car, and the fuel cells are used as like battery in the car. Okay. But if we can produce hydrogen or clean hydrogen, okay, we can achieve a condition where the harmful emissions are minimized. Okay. So, this is an important feature. Another important feature is higher efficiency. So, if you have again you have seen, or you can again look back the efficiency which I talked about of various fuel cell, some of the fuel cells efficiency are quite high. In general, fuel cell efficiencies are quite high. Now, it depends when we consider an energy storage device or an energy generation device, it depends on what are the stages of processes that it undergoes. Okay. So, let me just compare some of the important energy generation devices, okay, or energy storage devices, and let me see where actually the fuel cell stands. Okay. So, you can plot a power output in megawatt in terms of efficiency. So, look at this is the line for fuel cell, and you can see that is a almost a static line, okay, keeping 50 to 60% efficiency. In some cases it is even higher, people have shown higher efficiency also, but it seems that it is maintaining a steady efficiency for a large output power range. So, output power has started from 1 megawatt to 1000 megawatt scale, and where we can see 100 megawatt, which also the fuel cell, the efficiency remains almost steady. Okay. Little bit of variation when you go from one fuel cell to another fuel cell. So, that means it not only gives high efficiency, okay, it also remains maintain a steady efficiency for a quite a broad range of power output. Now, if you consider it with other, so this is actually gas turbine single cycle. Okay, you can see that how the efficiency varies when you use a gas turbine single cycle. When you are at a lower, the power, the efficiency is low, then eventually efficiency increases, but there is a variation of efficiency and the total efficiency is less than fuel cell. Similarly, you see the internal combustion engine, which is a very important thing, because most of the engines which we use are internal combustion engine. Okay. So, internal combustion engine is a competitive, the power generation process or power generators with fuel cell. And if we just compare these two, you can see that internal combustion engine efficiency is much lower as compared to the fuel cell efficiency. Okay. Of course, you can see the gas turbine or gas turbine combined cycle, but okay, you can have a highly efficient fuel cell when you consider higher temperature as well as gas turbine hybrid system. Both of them are highly efficient, maintaining an almost steady efficiency over a high output power range. Okay. But in normal cases, what are the equipments that we consider as the system or the devices for the energy delivery or the power, say fuel cell and the combustion engine, battery, etc. These are the things which we see people use, although we do not see much fuel cells are used here, but in some other countries people use fuel cells in various purpose. Okay. So, as I mentioned that efficiency depends on various processes that a system undergoes. What do we mean by that? The meaning is that suppose I want to generate electricity. Okay. So, what is the output? Output is electrical power. So, in a fuel cell or in a gas, in a combustion engine, when I generate electricity or electrical energy, what are the stages I go through? Similarly, when I consider a generation of mechanical energy, that is also possible, okay, from the basics of fuel cell or the combustion engine, what are the stages we undergo? Okay. If the stages that we undergo to generate the output energy which is desirable are more, then efficiency will be less, because in every step, every stage there is a loss in power. Okay. So, that means what you would like to do, suppose you make a power generation system, maybe a fuel cell or a battery or any kind of engine, what you like to do, the output power or the output energy should be, I mean, almost going through the your input to output. Let me make it more clear to you by a diagram, that how for different the energy systems or energy generators, there are various processes involved. So, first I take a situation where energy conversion, when it is you consider the output energy as electrical energy. So, this is your device, suppose heat engine, and what you want to get, the electricity. You start with the heat engine, okay, and you want to generate the electricity. So, what you want to that convert, you convert this energy of the heat engine to the electrical energy. But for that you have to undergo a chemical process, you also have to go through a thermal process, you also have to go to a mechanical process, and finally you get electrical energy. So, you can see so many processes you have to go through in order to get your final energy required, and therefore, there are more losses, that every stage you work, every stage your losses are more, eventually giving you relatively lesser energy. But if I consider fuel cell, it is only two stage, chemical to electrical, very simple. I start with a fuel cell, pass fuel, and then I give oxidant and then trigger a reaction. So, there is a chemistry. So, it is converted to chemical energy, and this chemical energy gets directly converted to electrical energy. That is what we have seen in different fuel cells. Okay. So, therefore, the transformation of energy from one stage to another stage goes through a very little change, only a chemical stage which we pass through, and therefore, the efficiency is higher because the loss is less. Similarly, we see in case of battery also, it is a chemical stage and then it produces electricity. But remember that we do not even think about using batteries for the for electrical grid or large scale circulation of electricity. Okay. These are the devices which generally used for a small scale electricity generation, suppose one house or few houses, okay, or a very small equipment where we use battery. But fuel cell covers both the sides, for small to large. Okay. Now, I consider the case where mechanical energy is generated. Okay. Mechanical energy is the output energy. Now, again you take heat engine. Heat engine, first it goes through chemical transformation, then thermal, and then mechanical. So, there are three stages. Now, if you come to fuel cell also undergoes three stages. That means, there is a fuel cell, it goes through chemical, it goes through electrical, and then mechanical. Okay. So, if you have to generate the mechanical energy for fuel cell, you have to go through the electrical process also, not directly from chemical to mechanical energy. So, therefore, you have another stage. And similarly, for battery, you have chemical, you have electrical, you have mechanical. This means that when I consider these three energy generation process or energy generating devices, we undergo almost same number of transformation steps to achieve the mechanical energy. So, that means when we talk about the mechanical energy generation by different the systems as I mentioned here, the efficiency seems to be almost at par, almost same, because it has all of them had gone through 3 different transformation stages or the energy transformation stages. Okay. But when you consider the electrical energy, we have seen the fuel cell is much better, much efficient as compared to heat engine. Okay. So, this is the way you the characterize this energy conversion, and then you define the efficiency and comment about which one is more efficient and why. Now, I just make a little summary of various features. Okay. So, what are the various features so far we have discussed that, and also I write it in terms of advantages and disadvantages, the summary of features. So, if you look at this only for fuel cell, the pollution is extremely less or no pollution in fuel cell. Now, we understand what is the reason, but hydrogen infrastructure is a very important thing as I mentioned, because if hydrogen infrastructure is not enough, okay, just remember that model car where we have shown that there should be a hydrogen storage. Okay. And that infrastructure should be good enough and it should be adequate enough to add it with a particular equipment, okay, or a particular device or a particular the transport system, all right. So, this is a point that the maturity of the hydrogen infrastructure is not yet adequate to, or it requires more technology to couple with a fuel cell. Now, the second point as I mentioned just now, that it is having higher thermodynamic efficiency, and we explain why you see a higher efficiency of fuel cell when we consider the generation of electrical energy, but there is an issue or sensitivity issue with the contaminants of the fuel cell. Okay. So, that one is to take care, because when you use lot of chemicals in the fuel cell, there is always an issue with the contamination. Modularity and scalability, there is a very important advantage of fuel cell. You remember that in the last class I have shown you huge fuel cell, okay, which actually is delivering power to a particular housing complex. Okay. So, how it is possible? Your fuel cells are small enough and you can make stacks of fuel cell. So, every fuel cell can be having small modules which can be stacked in a big fuel cell, okay, and one can make a good power generation a generating device using this stack. So, modularity and the scalability, that means you are scaling up the technology, the power is getting scaled up when you use the stacking of fuel cell, okay, and make a power generation device. And then you have a disadvantage because you have a thermal and water management associated with that. That one is to take care, because this is not as a disadvantage, but this is definitely an important point that one is to take care that thermal and water managements are perfect. Another very important feature of fuel cell is quiet and static. Okay, it does not produce any, not only it produces any pollution, it does not create any sound. Okay. So, you can have almost a very quiet energy generation source, which as that is why I told you that when you consider say the energy generation or energy distribution for some 50-60 houses, it is a very good system. You install it somewhere, okay, and then they connect all the houses with this fuel cell stack. Okay. It does not produce any noise. So, it not only produces harmful emission, but also it is quiet and it is static. Its performance is quite static, we have seen that. Okay. but when we do it, we also have to take care of cost. Okay. So, that I also discussed in my previous lecture, it is having higher cost. Now, range of application is another very important feature of fuel cell, and I will just come to this point, this particular issue again separately, that what are the range of application of fuel cell that is unique in case of fuel cell. And that is why there are so much thirst in fuel cell over last 2 decades. Lot of the money was involved in fuel cell research and generation of power. Okay. Because of range of application which I mentioned, that you can have a fuel cell which is used for a very small device, a small car, some automobiles, and then you can have a large scale the power generation process for a community, all right. But then once you are stacking and you have bringing various modules and making a stacked big fuel cell, then there are some mechanical issue, there is this weight and the system size, dimension, etc., or sometimes it is constraint, not very big disadvantage, but it is sometimes it is a constraint. Okay. But it seems that fuel cell is a quite good the system for energy generation. But now let us come to some important application of a fuel cell. So, if you categorize the application of fuel cell, okay, fuel cells are basically applied in 3 processes or 3 appliances. So, what are these? It could be a portable application that I mentioned, it can be a static application, or it can be a transport application or transportation application. So, you can see this particular, this is an automobile, I showed it to you, okay. But then you see how the construction of this, again remembering that how this fuel cell looks like, and this is actually fuel cell where you typically in a car, okay, or automobile you put a battery for power generation. Instead of that you put a fuel cell and you have a hydrogen tank, and there are some super capacitor, okay, to provide the energy. So, the design of the car is in this case is slightly different. So, if we look at schematically how it looks like, so this is your driving motor, okay, and this is your fuel cell stack which is here. You put few fuel cell, put it in stack like a battery which you have, and this is high pressure hydrogen tanks which you have to mount. And therefore, as I mentioned that it is always important to make a hydrogen infrastructure or hydrogen storage infrastructure in any fuel cell devices or appliances that you use. And then there is a cooling system. Ultra capacitor is used in this stage and driving motor stage. Okay. There are some air supply, okay, to this fuel cell stack. So, this is a way your schematic. If you look at any the mechanical engineering drawing of any engine, you will find almost similar thing, only what you have done here slightly different. You have used instead of battery a fuel cell stack, and then you connect it with a hydrogen storage. Okay. Now, let me just summarize all the applications in 3 sections. As I mentioned that applications are portable, applications are transportation, application is stationary. So, when we talk about portable application, what we mean that it is used in portable power generators. We all know that how to use portable generators, power generator, and what is the importance of portable power generator. It can be used in consumer electronics, okay. It can be used in portable military equipment, because in military there are a lot of portable devices which they would put a fuel cell with that as the energy devices, and it can be used as military devices. It can be also used as battery chargers. It can be used as very small equipment or gadgets like toys. Okay. So, you can see that these are all portable application of a fuel cell, but now I go to slightly the bigger application, that is transport. So, you can have an auxiliary power units, you can have light traction vehicles, one particular model which I have shown, you can have a light fuel cell electric vehicles, okay. You can have heavy fuel cell electric vehicles, okay. This light and heavy vehicles we all know in case of the diesel engine or engine, petrol engine, whatever we use presently. You can have a marine propulsion, you can have an aerial propulsion. So, these are all transportation application. Now, I come to stationary application. It is very interesting. You can have a distributed power generation. So, you can see the gadget started, the application started from a small gadget, and now we talk about the big application like distributed power generation. There is a combined heat and power. Okay, this is another very important aspect of fuel cell. This is known as CHP, combined heat and power. Because basic function of fuel cell tells that along with water we also have electricity and heat both. So, when we talk about the efficiency of a fuel cell, please remember that there are two efficiencies we generally defines. One is the electrical efficiency, which is only purely for how much electricity you are generated, and then another is CHP efficiency. So, one is electrical efficiency, another is CHP efficiency. And when you look at the literature of fuel cell, you will always find that these two efficiencies are defined properly and they are discussed. Okay. It can be used for combined cooling of heat and power, it can be used for backup power supply. Okay. You can use it for uninterrupted power supply like big UPS system, okay, and remote area power supply. That is what I told you, that the remote area where which cannot be connected with the main grid of power, one can use fuel cell stack there to generate the power. Okay. So, now I just give you a broad idea of the application of fuel cell, and I want to just tell you that when we discuss different fuel cell, which fuel cell is used for what. So, again I come to AFC. Okay. So, you all know that operating temperature or system power output that we have already discussed and what is the efficiency range, but let me just look at that what are the application that one uses for AFC. It is basically used for military and space. Okay. I also showed you a space shuttle in the last lecture, where basically the drinking water generation and all these things were used, a fuel cell is used. Now, PAFC is particularly a distributed generation. Okay. So, if we consider AFC, its efficiency is around 80%, and when we consider PAFC, efficiency is slightly higher. Now, SOFC, okay, it is used as auxiliary power, it is used as electrical utility, it is used in large distributed generation. Okay, this is a very important thing of SOFC, and it is having higher efficiency that I already discussed. Now, look at MCFC, which is also I mean the efficiency what I am now talking about, they are all CHP efficiency. Combined heat and power efficiency is around the 80%, and it can be used for electrical utility, and it can also be used as large distributed generation. Now, PEM 70 to 90% efficiency, CHP efficiency, and these PEMs are, as I mentioned, that you can have the backup power, okay, backup power, portable power, small distributed generation, okay, and vehicle transportation, etc. All right. And now come to last one, the DMFC. It is around 80% of CHP efficiency. It is now you come to a very small device, replace battery in the mobile. Okay, this is one important application of DMFC, and then computer and other portable devices. We already discussed that computer and other thing, you use battery or use lithium ion battery, etc. it seems that a particular kind of fuel cell can be used there also. Okay. Fine. So, let me just make summary of today's lecture, what we have discussed. We have compared various FCs. We looked at what are the different chemical reaction, chemical used in different fuel cells, okay, and what are the fuels used for different fuel cell, what are the reaction product, and then we have also seen for different fuel cell what are the efficiencies. Okay. And finally, we also looked at in terms of application how these different fuel cells are used in which application domain. We also discussed various features including advantages and disadvantages of fuel cell, and then I just mentioned about for one particular fuel cell, that is PEMFC, what are the stack components and what are their function, and then we discussed about applications of fuel cell. Okay. So, in the next class we will discuss little more about the material aspect, that means what are the materials we use in the fuel cell and how they are actually designed in a fuel cell. Okay. Thank you.